Hello everyone, Dennis here. In this video, I'm going to discuss review GCE O Level Additional Mathematics October-November 2020 paper 1. The subject code is 4047. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us. Question 1. The roots of the quadratic equation 2x squared minus 5x plus 8 equals to 0 are alpha and beta. Find a quadratic equation whose roots are alpha over beta and beta over alpha. Total 5 marks. Okay, so here's the solution. This question is quadratic inequality chapter. So given the equation 2x squared minus 5x plus 8 equal to 0, so we can determine the value of a, b, and c. So for this case, a is 2, b is negative 5, and c is 8. Then from here, we can find the sum of roots alpha plus beta, which is equal negative b over a, and it is negative bracket negative 5 by 2. Simplify, we get 5 over 2. We also can get the product of roots, which is alpha beta equals c over a. So for this case, it is 8 over 2, and simplify, we get 4. Then we move on for the new equation. The sum of roots is alpha over beta plus beta over alpha, which we can simplify, or we combine them together, we get alpha squared plus beta squared over alpha beta. So alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta then over alpha beta. So from here, we know the value of alpha plus beta, which is 5 over 2. We know the value of alpha times beta, which is 4. So substitute it into this equation, we get 5 over 2 squared minus 2 times 4 over 4. We simplify, and the answer is negative 7 by 16. Then we move on to find the product of roots alpha over beta times beta over alpha. This is very simple, which will give us 1. So from here, also can be 16 by 16, right? What's the reason? Because we want to make the sum of roots and the product of roots, right? Their denominator has the same value, okay? Because we know that sum of roots is negative b over a, so the b new and the a new. Similarly, for product of roots is c over a, so we have the c new and a new here. Then we know that the value of a is 16, the value of b new is negative 7, and the value of c new is 16. So we can form the equation now, ax squared plus bx plus c equal to 0, and the answer is 16x squared plus 7x plus 16 equals 0. Question 2. A. Given bracket 50 over 3 to the power negative 2 times square root of 3 cubed divided by 5 over 2 equals 2 to the power a, 3 to the power b, 5 to the power c. Find the value of a, b, and c. 3 marks. So the strategy to get the answer is, you can see that we want the left hand side and the right hand side, we want to make them to have the same body so that we can compare the power. So here's the solution. So given this is the equation, you can see that the left hand side, it is a lot of things. The first one is we have the fraction with the power negative 2 here. Then we have the square root and the 3 cube here, a bracket, operation of multiplication, then divided by a fraction. Alright, so we have to rearrange the left hand side so that it will be in the form of 2 to the power of something, 3 to the power of something, and 5 to the power of something. Okay, so the first thing we do is, right, we take care of the negative power here. We get 3 by 50 square, right? So because the negative becomes positive, we swap or change it to be in the reciprocal form. And for the square root here, we change the power to be a fraction power, so it becomes 3 to the power of 3 over 2. Then the division we change to times so that the fraction here becomes reciprocal. Alright, so this is the first thing we do. Right, the next thing we do is we'll try to change those numbers right into the index notation. So 50 will be 2 times 5 square. The rest we don't do anything, we just copy down. Then we open the bracket. So 3 square, so the 2 here is 2 square times 5 to the power 4, because when you remove the bracket, the power multiplies. So it's 5 to the power 4. Then the rest, actually we just remove the bracket because we don't need it anymore. So now it is clearer, right? We have operation of times and division. Now we can summarize them. Okay, so the body 2 here, right? At the top we have 1 here, 2 power 1. Then divide by 2 square, so it becomes 1 minus 2. Right, the body 3, the top here we have 1, 2 here, right? So only 2, then multiply. So add the power, become 3 to the power 2 plus 3 over 2. For the 5, we can see that the top we don't have, only have the bottom here, 5 to the power 4 and 5 here. So it becomes 5 to the power negative 4 minus 1. Then we simplify, becomes 2 to the power negative 1 times 3 to the power 7 over 2 times 5 to the power negative 5 equals to 2a, 3 to the power b, and 5 to the power c. So by comparing the power, we can see that a equals to negative 1, b equals to 7 over 2, and c is negative 5. This is the answer. Alright, question 2b. The value of a painting increases by 7% each year. Given that its value at the beginning of 2014 was $1 million, find its value to two significant figures at the beginning of 2020. 2 marks. Okay, so here's the solution. Firstly, understand the question, right? The value of this painting increased by 7% each year. So from here, it is similar with the concept of compound interest. Okay, so at the beginning, it is this value, right? So what is in the beginning of 2014, right? It is $1 million. So what is the value at 2020? All right, so from 2014 to 2020, there are 6 years. Okay, so compounding effect, or very similar to compound interest, right? The value in 2020 will be p bracket 1 plus I to the power n, where the p is $1 million, which is the initial value. Okay, the I is a 7% increment, right? So it's 1 plus 7 or 100 to the power of 6. Okay, then we just press calculator. The answer is $1,500,000. Okay, question 3. Express 4x squared minus 7x plus 9 over 2x squared minus x minus 3 in partial fraction. 5 marks. So here's the solution. For partial fraction, the very first step we need to do is we need to check the fraction here, is it a proper or improper fraction. So for this case, it is improper fraction. The reason is because the power of the x, the largest power of the x, both are the same. In the numerator and the denominator, both are square here. So what we need to do is we have to do long division to change it into proper fraction. So long division, the dividend is 4x squared minus 7x plus 9. The divisor is 2x squared minus x minus 3. So 2x squared times 2, we get 4x squared. Then continue with 2 times negative x, we get negative 2x. Negative 3 times 2, we get negative 6. Right? After that, the top minus the bottom. Right? So 4x squared minus 4x squared cancel each other. Negative 7x minus negative 2x, we get negative 5x. 9 minus negative 6, we get 15. Right? So this is the remainder. Then we can rewrite the fraction here, right? It becomes 2 plus negative 5x plus 15 over 2x squared minus x minus 3. This is the remainder divided by the divisor, right? Then from this fraction, we can factorize the denominator. 2x squared minus x minus 3 is x plus 1 times 2x minus 3. So we can break it into two fractions, which is a over x plus 1 plus b over 2x minus 3. Our next job is to find the value of a and b. So what we do is we combine these two fractions again, right? We should get the same fraction as the previous step here. So when you combine them, we get a times 2x minus 3 plus b times x plus 1 over x plus 1 times 2x minus 3. So from here, right, we compare the numerator, which is here, right, negative 5x plus 15 equals a times 2x minus 3 plus b times x plus 1. Okay, this is the original fraction. So now we let x equals to negative 1. So the left hand side is negative 5 times negative 1 plus 15 equals a bracket 2 times negative 1 minus 3 plus b bracket negative 1 plus 1. So from here we can see that the b is cancelled because negative 1 plus 1 is 0. So when we left with a, we solve this equation. 20 equals to negative 5a, a is negative 4. Next, we just choose any value of x. To make the calculation easy, we just choose x equal to 0, right? So the equation becomes like this: negative 5 times 0 plus 15 equals 4, negative 4 bracket 2 times 0 minus 3 plus b bracket 0 plus 1. We solve this equation. 15 equals to 12 plus b equals to 3. Hence, the partial fraction will be 4x squared minus 7x plus 9 over 2x squared minus x minus 7 equals 2 minus 4 over x plus 1 plus 3 over 2x minus 3. Question 4. Given this diagram, so the diagram shows part of the graph of y equals 2x minus 3 over x squared plus 4. Find the value of x which y is increasing. 4 marks. Alright, so from this question, the key or the important keywords is the y is increasing. Okay, so what does it mean when the y is increasing? Let's look at the solution. When y is increasing, it means that the dy over dx is greater than 0. Therefore, we have to find dy over dx. So y equals 2x minus 3 over x squared plus 4. So we can use the quotient rule. Dy over dx equals x squared plus 4 bracket 2, differentiate the numerator, right, minus, so this is the numerator, 2x minus 3 times if differentiate the denominator, we get 2x over, so the denominator square, x squared plus 4 square, right? Then we simplify. The top is 2x squared plus 8 minus 4x squared plus 6x over x squared plus 4 square. And we get 8 plus 6x minus 2x squared over x squared plus 4 square. So since it is increasing function, therefore dy over dx is greater than 0. Substitute 8 plus 6x minus 2x squared over x squared plus 4 square greater than 0. So we know that the denominator x squared plus 4 square is always greater than 0. Therefore, 8 plus 6x minus 2x squared must be greater than 0. We solve this quadratic inequality by rearranging it to be 2x squared minus 6x minus 8 less than 0. Divide by 2 for both sides, we get x squared minus 3x minus 4 less than 0. We factorize it, we get x plus 1 times x minus 4 less than 0. From here, we can sketch the graph. So here is negative 1, here is 4. Okay, it is a smiley face. Right, it must be less than 0, so everything is below the graph. Therefore, the range of the x is negative y to 4. Question 5. Given this graph, okay, the diagram shows part of the graph of y equals modulus 7 minus 2x. The line y equals mx minus 2, where m is a constant, cuts y equals modulus 7 minus 2x at 2 distinct points. Explain why. The m is between 4 by 7 to 2, 4 marks. Alright, so now read this question. Right, we have this modulus function, and this is a linear graph. Okay, so it should be something like this, right? Increasing function, because you look at the range, it must be positive, so it will be an increasing function graph. Okay, and if it wants to cut this graph into two distinct points, the range of the gradient must be between these two values. Okay, so now here's the solution. We have these two equations, y equals modulus 7 minus 2x and y equals mx minus 2, right? So since we want to make them to cut each other in at two distinct points, the value of y are the same. Therefore, we can equate both equations. Modulus 7 minus 2x equals mx minus 2. So we solve this equation, right, by squaring both sides. We get 7 minus 2x squared equals mx minus 2 squared. Expand the brackets. We get 49 minus 28x plus 4x squared equals m squared x squared minus 4mx plus 4. Then we make one side to be 0. So 0 equals m squared x squared minus 4x squared minus 4mx plus 28x plus 4 minus 49. Right? We can factorize out the x squared and the x. We get 0 equals m squared minus 4 x squared plus bracket 28 minus 4m x minus 45. So from here, right, it is a quadratic equation. The a is m squared minus 4, the b is 28 minus 4m, c is negative 45. So we need them to cut each other at two distinct points. Therefore, b squared minus 4ac is greater than 0. So we substitute the b, a, and c here. We get 28 minus 4m squared minus 4 bracket m squared minus 4 bracket negative 4 t5, then greater than 0. Next, expand the brackets here. We get 784 minus 224m plus 16m squared plus 180m squared minus 720 greater than 0. Okay, simplify further. We get 196m squared minus 224m plus 64 greater than 0. Okay, so everything divided by 4, we get 49m squared minus 56m plus 16 greater than 0. Okay, so we can factorize. It becomes 7m minus 4 squared greater than 0. Okay, which means that 7m minus 4 is greater than 0. Therefore, m should be greater than 4 over 7. So which satisfy here, right? The first part of the inequality. So next, what happened to the second part? M must be less than 2, right? So now when m is equals to 2, right, what will happen? The line y equals mx minus 2 will be parallel with the positive gradient of y equals modulus 7 minus 2x, right? Because over here, right, this is the increasing function. We can see that the gradient is 2, right? So that means if I want to plot this graph, right, when m is 2, y equals to 2x minus 2, it will be parallel with this line. Okay, so which means that this red line will not intersect with this line. Okay, so there will be only one point intersection with these two graphs. Therefore, right, the m less than 2 cut at two distinct points. Okay, so we join these two inequality together. So the m, right, must be greater than 4 over 7 and less than 2. Question 6. Find the coordinates of the stationary points of the curve y equals x squared plus 4 over x squared and determine the nature of each stationary point. 6 marks. Alright, so for this question, I would say it is a very classical question, right? Just give you the equation and ask you to find the stationary point. After that, the next thing you need to do is to determine the nature of the stationary point. So the steps are pretty standard. Okay, so the first thing is, given y equals x squared plus 4 over x squared, right? We make it to be indices form first, right? Y equals to x squared plus 4x to the power negative 2, so that we can differentiate this equation easily. So dy over dx equals 2x minus 8x to the power negative 3. Alright, so rearrange it, right? It becomes 2x minus 8 over x to the power 3. Alright, since we want it to be a stationary point, therefore dy over dx should be equals to 0. Substitute, we get 2x minus 8 over x cubed equals to 0. Then we solve this equation. Okay, everything, both sides times with x cubed, we get 2x to the power 4 equals negative 8 equals 0. So x to the power 4 equals 4. Okay, so x will be plus minus 4 roots of 4, which means x equals to square root of 2, or x equals to negative square root of 2. So we can substitute the x value into the original equation to find the coordinates, the y coordinate of the point. So y equals to sec2 square plus 4 over sec2 square, or y equals to negative sec2 square plus 4 over negative sec2 square. Alright, so from here, be careful with the sign. Okay, so the first part we get y equals to 4, and the second part actually we get the same value, y equals to 4. Therefore, the 2 points will be, we'll talk about it later, right? So d square y, the next part we need to do is we want to determine the nature of each stationary point. So d square y over dx square, right? We differentiate second time from here dy over dx, we get 2 plus 24x to the power negative 4. And simplify, we get 2 plus 24 over x to the power 4. So we substitute for the first point, the x is sec2 and y is 4. So substitute x goes to sec2 into d square y over dx square. So we don't have to calculate the actual value, but we can see that it must be positive. So this point, sec2, 4, is the minimum point. For the second point, x equals to negative sec2, y equals to 4. So the d square y over dx square equals 2 plus 24 over negative square root of 2 to the power 4. Again, we don't want to calculate the actual value, but we can just see that we will get a positive number. So this point, negative sec2, 4, is a minimum point as well. Question 7. Solve the equation 3 cosine A equals secant A minus 5 tangent A for the range of A greater than 0 degrees and less than 360 degrees. 7 marks. Okay, so here's the solution. 3 cosine A equals secant A minus 5 tangent A. So we can see that most of the trigo here, right, it is not a usual trigo. We have the secants, we have the tangent. So we have to change them into the usual trigo, which is cosine and sine. So for the secant A, it will be 1 over cosine A. For the tangent A, it will be sine A over cosine A. Alright, so that we can solve this easily. So from here, we multiply cosine A for both sides. We get 3 cosine square A equals 1 minus 5 sine A. Alright, so from here, we can see that we have two different trigo, cosine and the sine. So we maybe want to think of standardize the trigo, right? Either we make it to be cosine, everything to be cosine, or sine. Okay, so we can see that cosine square A, it is easier to change to sine, right? By applying the basic identities formula. For cosine square A is 1 minus sine square A. So the equation becomes 3 times 1 minus sine square A equals 1 minus 5 sine A. Then we expand the bracket. Here we get 3 minus 3 sine square A equals 1 minus sine A. Okay, so I can see that this equation, it becomes a quadratic equation. Okay, so we move everything to the right hand side. The left hand side is 0. So 0 equals to 3 sine square A minus 5 sine A minus 2. Because we want to make the coefficient of the sine square A to be positive so that we can calculate easier, right? So this is a quadratic equation. Factorize it. Okay, 0 equals to bracket sine A minus 2, then times 3 sine A plus 1. Okay, so we can equate sine A minus 2 equal to 0, or 3 sine A plus 1 equal to 0. Okay, so that means sine A equals to 2 or sine A equals to negative 1/3. We know that sine A cannot be more than 1. Therefore, sine A equals to 2 has no solution. For sine A equals to negative 1/3, right? First thing is to solve it, we want to find the basic angle, which equals to inverse of sine 1/3. So when you press calculator, we get 19.5 degrees. So we look at this equation, the sign is negative, right? Negative 1/3 here. That means the angle is at quadrant 3 and quadrant 4. Therefore, the angle A is 180 degrees plus the basic angle 19.5 degrees, 360 degrees minus 19.5 degrees. So the answer will be A equals 199.5 degrees and 340.5 degrees. Okay. Question 8. Part A. The remainder when x cubed plus ax, where a is a constant, is divided by x minus 2 is the same as the remainder when it is divided by x plus 1. Find the value of a. 3 marks. Okay, so read this question. We can see that this is the dividend x cubed plus ax. When it is divided by the divisor x minus 2, right? The remainder will be the same when divided by x plus 1. So from here, we can apply the remainder theorem, right? Okay, so by remainder theorem, the remainder equals to fb, where when a polynomial is divided by x minus b. Okay, so from here, given that the fx is x cubed plus ax, the remainders are the same when divided by x minus 2 and x plus 1. Therefore, it means that f2 equals f negative 1. Then we substitute the value of the x is 2 and negative 1. For both sides, we get 2 cubed plus a times 2 equals negative 1 cubed plus a times negative 1. So we get 8 plus 2a equals negative 1 minus a. Then we solve this equation. 3a equals to negative 9 and a is negative 3. Okay, part B, solve the equation x cubed minus 2x squared minus 4x plus 3 equals 0. Expressing non-integer roots in third form. 4 marks. Here's the solution. Firstly, we let fx to be x cubed minus 2x squared minus 4x plus 3 so that we can substitute easily, right? So by trying an error method, right, we find that f3, where x equals to 3, substitute inside this equation, x cubed minus 2x minus 2 times 3 squared minus 4 times 3 plus 3, we get 0, which means that x minus 3 is a factor. Alright, so the next step we need to do is we want to factorize this expression. There are two ways we can do. The first way is to do long division. So firstly, we put this as the dividend, x cubed minus 2x squared minus 4x plus 3. The divisor is x minus 3. So long division, firstly x squared times x minus 3, we get x cubed minus 3x squared. So the top minus the bottom, we get x squared. Then copy down 4x plus 3. So the next one, x minus 3 times x, we get x squared minus 3x. And the top minus the bottom, we get negative x. Then copy down the 3 here. So now x times negative 1, we get negative x plus 3. We should expect to get the remainder as 0, because x minus 3 is a factor. Okay, there is another way we can do it. We can use a synthetic method, right? By copy down all the coefficient of this expression, x cubed minus 2x squared minus 4x plus 3. So it is 1, negative 2, negative 4, and 3. Alright, and then we draw this line. And 3 here because x minus 3 is a factor, right? So first thing is copy down the 1 here. Then 3 times 1, we get 3. So negative 2 plus 3, we get 1. So the next step, 3 times 1, we get 3 here. So negative 4 plus 3, we get negative 1. So next thing is 3 times negative 1, we get negative 3. So 3 plus negative 3, we should get 0 here because this tells us the remainder. And again, x minus 3 is a factor, the remainder must be 0. Okay, we get all these numbers here, 1, 1, and maybe 1. So these are the coefficient of the quadratic factor. Okay, so now we can rewrite the equation x cubed minus 2x squared minus 4x plus 3 equal to 0. Factorize it, it is x minus 3, which is the first linear factor, right? And x squared plus x minus 1, this is the quadratic factor. The values we can get from here, or the synthetic method, right? 1, 1, and negative 1, x squared plus x minus 1. Okay, so now we solve separately. The first factor, x minus 3 equal to 0. Therefore, the next one is x squared plus x minus 1 equal to 0. So x minus 3 equal to 0 means that x equal to 3. And the second part, we actually cannot just factorize with the bracket method. Okay, we can either use formula method or we use completing the square method. So over here, I show you with the completing the square method. Okay, so x plus half square minus half square minus 1 equal to 0. Right, then simplify, we get x plus half square minus 5 over 4 equal to 0, which means x plus half square equals to 5 over 4. So x plus half equals to plus minus square root of 5 over 4. Okay, it can be x equals to negative half plus 5 over 2, or x equals to negative half minus 5 over 2. Of course, if you want to use formula method to solve this quadratic equation, should be fine. You will get the same answer. Question 9. The equation of a circle is x squared plus y squared plus 4x minus 6y minus 12 equals 0. 1. Find the radius of the circle and the coordinates of its center. 4 marks. 2. Find the equation of the tangent to the circle at point 17. 3 marks. Alright, here's the solution. Firstly, we need to find the circle, the radius, and the coordinates of the center. Right? So there are actually two ways we can find. Either we can use the formula method, or we can use the completing the square method. I would prefer to use completing the square method because I don't have to memorize the formula. Okay, so now for the first one, we have this equation x squared plus y squared plus 4x minus 6y minus 12 equal to 0. So I will group the x terms and the y terms together first so that I can do completing the square easily. The equation becomes x squared plus 4x plus y squared minus 6y minus 12 equal to 0. Okay, now we can perform completing the square, which is x plus 2 square minus 2 square plus y minus 3 square minus negative 3 square minus 12 equal to 0. Okay, you can see this is a constant and this is also another constant. Right, so we simplify, it becomes x plus 2 square minus 4 plus x minus 3 square minus 9 minus 12 equal to 0. Simplify further, we get x plus 2 square plus y minus 3 square equals to 25. So we leave all the constant terms right to the right hand side. Okay, and this is the standard equation of a circle, x plus 2 square plus y minus 3 square equals to 5 square. With information that we can get here, right, is this 5 square, it means the radius is 5. Okay, plus 2 and minus 3 here, right, which means the coordinates of the center will be negative 2, 3. Okay, so I've answered the first question. Now the next question, I want to find the equation of the tangent at the circle at point 17, right? So we apply the property of circle where the radius is perpendicular to the tangent. Okay, so we want to find the gradient of line passes through the center, negative 2, 3, and the point 17, which is this point, right? So which is m equals 7 minus 3 over 1 minus negative 2. Okay, so this is the formula of the gradient. We get the value is 4 over 3. So since the tangent is perpendicular to the radius, right? When we multiply their gradients, we'll get -1. Therefore, the gradient of tangent will be -3/4. Okay, and it passes through 0.17. Hence, now we can form the equation of tangent. Y minus 7 equals -3/4 times x minus 1. So this is the formula or the equation to form equation of a straight line. Then we expand the bracket. Y minus 7 equals -3/4x plus 3/4 and make y the subject. The answer is y equals to -3/4x plus 31/4. Question 10. Given this diagram, the diagram shows for the x range from 0 to pi inclusive, the curve y equals cosine 2x and the line y equals -3/2. The curve intersect at points A and B, okay, as described in this diagram. Alright, so firstly, find the x-coordinate of A and B. 3 marks. I think this question will be pretty straightforward, right? We can see that the point A and B lie on both y equals cosine 2x and y equals to -3/2. So we can equate these two equations together, which we get cosine 2x equals -3/2. Okay, so now we can solve this equation. Firstly, we find the basic angle, which is pi/6. Alright, now the next thing is, given that the range of the x is from 0 to pi, the angle in this equation is 2x, therefore the range of 2x will be 0 to 2 pi. So next thing is, cosine here is negative, therefore the points will be in quadrant 2 and quadrant 3. Hence, 2x will be equals to pi minus pi/6 and pi plus pi/6. Okay, we now start to solve this equation. So 2x is 5 pi/6 and 7 pi/6, which means that x equals to 5 pi/12 and 7 pi/12. So what does it mean? It means that the x-coordinate of A will be 5 pi/12 because A is at this level, at this point, right? And for x-coordinate of B, it will be 7 pi/12. So B is here, right? So this value will be 7 pi/12. And this is the answer. Part 2. Show all your working. Find the exact area of the shaded region. 6 marks. Okay, so here is the area of the shaded region. So firstly, we want to mark this point first, where it is 5 pi/12 and this is 7 pi/12, as these two values were found in part 1, right? So now I want to find the area under the curve first, which is this region. Okay, it is equals to modulus integration of 5 pi/12 to 7 pi/12 cosine 2x dx. Notice that I put a modulus sign here because we look at this diagram, it is below the x-axis, so I will expect to get a negative value. Since we want to find the area, we can just ignore the negative sign, right? Now the next step is integrate cosine 2x. I get negative sine 2x over 2 from 5 pi/12 to 7 pi/12. Okay, so substitute, right? And before that, I take out the half here. So substitute 7 pi/12 and 5 pi/12. We get sine 2 7 pi/12 minus sine 2 5 pi/12. Notice also I ignore the negative sign because, as I mentioned, it is a modulus sign here, right? We can ignore the negative value. Okay, so we get half modulus bracket sine 7 pi/6 minus sine 5 pi/6. We get half modulus negative half minus half, and the answer is half. So this is the area under the curve, which is here, right? So the next thing I want to find is the area of the rectangle, which is the unwanted part here, right? So this length is pi/6 and this length is 3/2. So the area of the rectangle will be pi over 6 times sub3 over 2. So we get sub3 pi over 12. To find the area of the shaded region, very simple, just the area on the graph minus the area of the rectangle, and substitute the value, which is half minus sub3 pi over 12 units square. This is the answer. Question 11. A motorcyclist traveling along a straight road passes a point A and 10 seconds later passes a point B. The motorcyclist's speed at B is twice his speed at A. For the journey from A to B, the motorcyclist's speed v meters per second t seconds after passing A is given by v equals 15 bracket t over 20 plus e to the power of k t from time 0 to 10, where k is a constant. 1. Find the speed of the motorcyclist at B. 1 mark. 2. Find the distance between A and B. 6 marks. And 3. Find the acceleration of the motorcyclist when t equals 2. 2 marks. The solution is for part 1, right? Before we want to find the speed of the motorcyclist at B, we need to find the speed of the motorcyclist at point A using given equation, right? So that means when it is at point A, the time is 0. So we substitute t equal to 0 into the equation given, we get VA equals to 15. So as given by the question, the speed at B is twice the speed at A. Therefore, at B, VB is equals to VA, and the answer for the speed at point B is 30. So question number 2, when the time is 10, B is 30. So we can substitute this information into the equation, right, to find the constant k. So the equation becomes 30 equals 15 bracket 10 over 20 plus e to the power of 10k. Then we solve this equation. We get half plus e to the power of 10k equals 2, which means e to the power of 10k equals 3 over 2. So 10k equals ln 3 over 2. K will be ln 3 over 2 over 10. And the answer for k is 0.04055. Therefore, we can rewrite this formula. V equals 15 bracket t over 20 plus e to the power of 0.04055 t. So why do we want to find this constant and reform the equation for the speed? Because we want to find the distance. So to get the distance, we need to integrate the v. So for this case, we get d equals 15 integration from 0 to 10 because the time is up to 10. Start from point A to 10, right? Point A time is 0, at point B time is 10. T over 20 plus e to the power of 0.04055 t dt. Then we can start to integrate. We get 15, so t squared over 40 plus e to the power of 0.04055 t over 0.04055 from 0 to 10. Then we just substitute the values. We get d equals 15 bracket 100 over 40 plus e to the power of 0.04055 over 0.04055 minus 1 over 0.04055. Alright, then the rest we just press calculator. We get the answer for the distance between A and B is 222 meters, which has been rounded off to 3 significant figures. Okay, for 3, we want to find the acceleration. So we know that acceleration is the differentiation of the speed. So A equals dv over dt. Okay, by differentiating the speed equation here, right, we get 15 bracket 1 over 20 plus 0.04055 e to the power 0.04055 t. So when t equals to 0, when t equals to 2 as given by the question, the expression will be just substitute t as 2, right? The rest is just the same. We just copy down. Then we just press calculator. We get the answer is 1.41 meters per second square, rounded up to 3 significant figures. Question 12. So the first instruction in question 12 is do not use a calculator in this question. Part 1. Show that sine bracket alpha plus beta plus sine bracket alpha minus beta over cosine bracket alpha plus beta plus cosine bracket alpha minus beta equals tangent alpha. 2 marks. Okay, so the solution for part 1, we start from the left hand side, right? So this is the whole expression, the sine alpha plus beta plus sine alpha minus beta over cosine alpha plus beta plus cosine alpha minus beta. Why we start from the left hand side? Because we can apply some formula, right, to reach the answer for tangent alpha. Okay, so from here we actually apply the addition formula. So for the sine would be sine alpha cosine beta plus cosine alpha sine beta. So the second one, sine alpha minus beta, with sine alpha cosine beta minus cosine alpha sine beta. For cosine alpha plus beta, we can change it to cosine alpha cosine beta minus sine alpha sine beta. And cosine alpha minus beta, we can change to cosine alpha cosine beta plus sine alpha sine beta. Alright, now from here, we can cancel cosine alpha sine beta here because this is plus, this is minus. Similarly, at the bottom, sine alpha sine beta can cancel out because here is negative, here is positive. Okay, so now at the top is 2 sine alpha cosine beta because look at here, sine alpha cosine beta plus sine alpha cosine beta, so it's 2. Similar for the bottom, cosine alpha cosine beta plus cosine alpha cosine beta, we get 2 cosine alpha cosine beta. And from here, we can cancel out the 2 and cosine beta. So you only left with sine alpha over cosine alpha. We know that sine over cosine, we get tangent. So from here we get tangent alpha, which is same as the right hand side. Hence, shown. Next question. Angle A and angle B are both acute and sine A minus B equals negative 3 over 5. Part 2. What can be deduced about the size of B relative to A? 1 mark. And part 3. Find the value of cosine A minus B. 2 marks. Okay, so the solution for part 2, we can see that sine A minus B is less than 0, right? Because it's negative value. Then the B should be greater than A. Okay, then part 3, we can use identity sine square A plus cosine square A equals to 1. So sine square A minus B plus cosine square A minus B equals to 1. So we know that sine square A minus B is negative 3 over 5. So from here substitute we get square plus cosine square A minus B equals to 1. Therefore, cosine square A minus B equals to 1 minus 9 over 25, which is 16 over 25. Therefore, cosine A minus B equals plus minus square root of 16 over 25, which is plus minus 4 over 5. Since A and B are acute, as given by the question, and B is greater than A, so A minus B must be in the 4th quadrant. Therefore, cosine A minus B equals 4 over 5, as cosine in the 4th quadrant is positive. Part 4. Given that cosine a plus b equals 7 over 25 and tangent a plus b equals 24 over 7, state the value of sine a plus b, 1 mark. Part 5. Using the identity from Part 1, show that tangent a equals 1 over 3, 2 marks. Part 6. Hence, find the exact value of tangent b, 3 marks. And the solution is for Part 4. The given information is cosine and tangent. We want to find sine. The angles are the same. So there's only one formula that links these three trigo, which is sine A plus B over cosine A plus B equals tangent A plus B. Okay, then we make sine A plus B the subject, which is equals tangent A plus B times cosine A plus B. Then we just substitute the values given. Tangent A plus B is 24 over 7. Cosine A plus B is 7 over 25. They multiply together, and the result is 24 over 25. For Part 5, from Part 1, we can modify the equation, which is tangent A equals sine A plus B plus sine A minus B over cosine A plus B plus cosine A minus B. Okay, so we have all the values here, right? Sine A plus B from here is 24 over 25. Sine A minus B from previous question, the value is negative 3 over 5. Cosine A plus B given is 7 over 25. And cosine A minus B also, we can get a value from the previous question. The value is 4 over 5. Then calculate the values, we get 1 over 3. Hence shown. So part 6. Now we want to find the exact value of tangent B. So we can again modify the equation from part 1, which we get tangent B equals sine B plus A plus sine B minus A over cosine B plus A plus cosine B minus A. So we can rewrite this equation. Okay, so for sine, there is no difference if for B plus A and A plus B. But for the sine B minus A, it is equals to minus sine A minus B. Similarly, for cosine B plus A, it is same as cosine A plus B. For cosine B minus A, it is also the same as cosine A plus B, A minus B. Okay, so after that, we just substitute everything, the values that we have. Sine A plus B is 24 over 25 minus sine A minus B, which is negative 3 over 5. Cosine A plus B is 7 over 25. Cosine A minus B is 4 over 5. Then we just calculate the value, and the answer is 13 over 9. If you think that this is too complicated, there's another way we can do. We can use the addition formula, which is tangent A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. Okay, so we have the value of tangent A plus B, which is 24 over 7. Tangent A is 1/3. Okay, so we can substitute here 1/3 at the top and 1/3 at the bottom. We're only left with tangent B, that is the one we want to find. So we can solve this equation, which is 24 over 7 minus 8 over 7 tangent B equals 1/3 tangent B. So 8 over 7 tangent B plus tangent B equals 24 over 7 minus 1/3, which means 15 over 7 tangent B equals 65 over 21. So tangent B will be 65 over 21 times 7 over 15, and the answer is 13 over 9. So it's the same value as this method. And that's all for this video. Thanks for watching. Do you have any thoughts, opinion, or experience to share? Write it down in the comments. We would love to hear from you. Do you like this video? Please don't forget to like and share to your friends. Until then, see you in the next video. Have a great day ahead.